In this video, we'll be learning about the binomial setting and the binomial formula. When we talk about the binomial probability distribution, we are referring to the probability of a success or failure in an experiment that is repeated multiple times. You can easily remember this by paying attention to the prefix by, which literally means two. For example, in bicycles, there are two wheels, and in binoculars, there are two lenses. However, in binomial probabilities, there are two outcomes, a success or a failure. Before we do some practice problems, we need to talk about the binomial setting. The binomial setting must satisfy four conditions. The first condition is that the number of trials n must be fixed. The second condition is that there are only two possible outcomes for each trial. You can either have a success or a failure. The third condition is that the probability of success must be constant for every trial. And finally, the fourth condition is that each trial must be independent. This means that the outcome of one trial does not influence the outcome of another trial. An experiment that satisfies these four conditions is called a binomial experiment. The binomial setting will make more sense after we doing example, so let's jump into it. If you flip a regular coin 3 times, what is the probability of getting exactly one head, and is this a binomial experiment? Since the question says that we are flipping the coin 3 times, I will have 3 blank spaces, one for each flip. The first blank space is for the first flip, the second is for the second flip, and the third is for the third flip. In order to solve this problem, we have to realize that there are only 3 possible ways for us to get exactly one head. The first way is to get heads on the first flip and then tails on the second and third flip. The second way is to get tails on the first flip, heads on the second flip, then tails on the third flip. The third and the final way is to get tails on the first and second flip and then getting heads on the third flip. So overall, we see that there are 3 different outcomes where we get exactly one head, and we see that they vary based on in the order. Now we all have to do is to calculate the probabilities of each outcome and add them together to get the answer. We know that the probability of getting heads is 0.5 and the probability of getting tails is also 0.5. To calculate the probability of the first outcome, we will multiply the probability of heads times the probability of tails times the probability of tails again. This is equal to 0.5 times 0.5 times 0.5. And this is equal to 0.125. When we calculate the probabilities for the second and third outcome, you'll find that they will also be equal to 0.125. Now all we have to do is add these probabilities together to get the answer. And when do we get the probability of getting exactly one head, which is equal to 0.375. To check if this is a binomial experiment, we have to see if this satisfies the 4 binomial conditions. The first condition is satisfied because we have a fixed number of trials n and is equal to 3. Because the experiment has to be repeated 3 times. In other words, the coin has to be flipped 3 times. The second condition is also satisfied because we can define success as getting heads and we can define a failure as not getting heads. This is the same as saying getting tails is a failure. The third condition is also satisfied because the probability of success remains constant for every trial. In other words, the probability of getting heads is 0.5 and it stayed that way every time the coin is flipped. And finally, the fourth condition is also satisfied because each trial is independent. Getting heads or tails for one trial doesn't change the probability of getting heads or tails. For the other trial, since all four conditions are satisfied, we know that this is a binomial experiment. Now, let's do harder problem. We have 10 marbles in the box. We have 3 pink marbles, 2 green marbles, and 5 blue marbles. If we pick all 5 marbles with replacement, what is the probability of drawing exactly 2 green marbles, and is this a binomial experiment? Before we calculate any probabilities, let's see if we have a binomial setting. Is there a fixed number of trials? Yes. N is equal to 5 because we are picking out a marbles. Are the two possible outcomes a success and a failure? Yes, a success is getting a green marble and a failure is not getting a green marble. Is the probability of success constant for each trial? Yes, because we're doing the experiment with replacement every time we conducted trial. Or randomly pick one marble, we put it back into the box before drawing another marble. If we didn't do this, the trial would become dependent on the another instead of being independent. In this case, the probability of success is equal to probability of getting one green marble, which is equal to 2 over 10 or 0.2. Are trials independent to each other for the reasons mentioned previously? The answer is yes. Since all 4 conditions are satisfied, we know that this is a binomial experiment. To solve this problem, we need to write all the possible ways of drawing exactly 2 green marbles. For example, one way is drawing a green marble on the first and second try, and then drawing a green marble on the third, fourth, and fifth try. Another way could be only drawing a green marble on the second and fifth try. Notice that I decided to write a dashed line for not getting a green marble. This is because I don't care if the marble was blue or pink. If I don't get a green marble, it's a failure in a binomial setting. We only care if we got a failure or success. Overall, we see that there are 10 different ways of drawing 2 marbles. We can probably reframe this by saying that there are 10 different ways of getting 2 successes and 3 failures. Now let's calculate some probabilities. The probability of success is equal to the probability of drawing a green marble, since there are 10 marbles in the box and only 2 of them are green. The probability of drawing a green marble is equal to 2 over 10 or 0.2. Therefore, the probability of a success is equal to 0.2. The probability of a failure is equal to their probability of not drawing a green marble. There are 10 marbles in the box and 8 of them are green. So the probability of not trying a green marble is just 8 over 10 or 0.8. Therefore, the probability of a failure is equal to 0.8. Let's calculate the probability of the first outcome. We have 2 successes followed by 3 failures. So we will have 0.2 times 0.2 times 0.8 times 0.8 times 0.8, which gives us an answer of 0.02048. If we do similar calculation of the rest of the outcomes, we should also get an answer of 0.02048. Notice how each of these 10 outcomes has the same probability. The reason of this is because each outcome has 2 successes and 3 failures, so it makes sense that they will have the same probabilities. Now, to calculate the probability of drawing exactly 2 green marbles, all we have to do is add up all these probabilities together. And when we do, we get an answer of 0.2048. However, there is another way we can calculate this answer, and that is by using the binomial formula. The binomial formula looks like this. It looks a little scary, but let's break it down. K is the number of successes, N is the number of trials, and little p is the probability of success. What we have here in brackets represents the combination of formula. It is often seen in scientific calculator as NCR, which is the same thing as saying N choose R. So for the binomial formula, we say that the probability of K is equal to N choose K times the probability of success, little p raised to the number of successes, K times the probability of failure, which is 1 minus p raised to the number of failures, which is equal to N minus K. By using this formula, we are essentially giving ourselves a nice shortcut for calculating things. However, it's important to remember that we can only use this formula if we have a binomial experiment. Let's go back to the problem so I can show you how to use this formula. If we pick 5 marbles with replacement, what is the probability of drawing exactly 2 green marbles? In this problem, N is equal to 5 since there are 5 trials. In other words, we are randomly picking up 5 marbles. K is equal to 2 since we are only concerned about gaining exactly 2 successes. This is the same as getting exactly 2 green marbles. Little p is equal to 0.2 as this is the probability of success that we calculated earlier. Now, all we have to do is plug these values into the formula and we'll get an answer. In other words, the probability of getting 2 successes is equal to 5. Choose 2 times 0.2 squared times 1 minus 0.2 raised to the power of 5 minus 2. After this calculation, we get an answer of 0.2048, which is the same answer that we calculated from before. That's all. Thank you.